Hello everyone, this is your Rahul sir. So today we will see how to draw the construction of a cam profile for a roller offset follower. In the last class we studied how to draw the cam profile for a roller inline follower, but today we will see how to do it for the roller offset follower. Okay, so just a recap. So we know there are three kinds of types of follower: knife edge follower, roller follower, flat faced follower, and we saw how to draw the cam profile for the knife edge and a flat face. Okay, today we will see how to draw it for a roller follower. So you see that's the sketch with the B, where how it looks like a roller, and then you have the inline, that is the inline follower and then offset follower. Okay, so inline means the follower will reciprocate in line with the cam axis, whereas in offset will offset by some distance. Okay, all right, so this is a problem, the same problem that we solved. Okay, but in this case the follower is offset. Okay, let us read it again. Please concentrate, this is for 20 marks. Okay, so a cam with 30 mm as minimum radius is rotating clockwise at a uniform speed of 100 rpm, has to give the motion as defined below. Follower to move outward through 40 mm during 120 degree of cam rotation, follower to dwell for the next 60 degrees, follower to return to its starting position during the next 90 degree. Diameter of the roller follower is 20 mm. The displacement takes place with uniform acceleration and retardation motion, both outward and return strokes. Draw the cam profile when the follower axis is offset to right by 10 mm from the axis of the cam. Okay. Also determine the maximum velocity and maximum acceleration during outstroke and return stroke. So if you see, it's the same problem, but here what we saw in the last class, but here the cam profile, the roller follower axis is offset to right by 10 mm, okay, from the axis of the cam, right? So we know that this is a roller offset follower, and again we have to first draw the displacement diagram and then to draw the cam profile. Okay, so these are the data we already know. Stroke 40 mm, angle of rise is 120. After that a dwell of 60 degree, and then again an angle of fall of 90 degree, and then again a dwell of 90 degree. Minimum radius of the cam is nothing but the base circle radius is already given as 30 mm. So keeping this in mind, we'll first draw the displacement diagram where the follower motion takes place in UARM. Okay. So this we have again drawn it. It's the same displacement diagram which we have drawn it in the last class. Okay, so I'm going to keep this as a reference and then draw further. Okay, I hope you know how to draw the displacement diagram, and the motion of the follower is UARM. Okay, so let us next see how to draw actually the cam profile. Okay, first, so in case of a roller follower, right now we have to for the inline follower we have drawn the base circle and the prime circle. Okay, but here, okay, point number one, draw the base circle whose radius is 30 mm, prime circle whose radius is 40 mm, and offset circle whose radius is 10 mm from the cam center O. Okay, so just like in the for the roller follower, you always start with the base circle. So they have given that, draw that. Then the prime circle. The prime circle is nothing but the perpendicular radius is nothing but radius of base circle plus radius of follower. Okay, so because of radius of roller follower. So because the base circle radius is 30 and the roller follower is 20 mm diameter, the radius is 10 mm. Hence the prime circle is 40 mm. Also, this roller follower is offset. Okay, so in case of offset, we are supposed to follow the offset circle, and here offset circle is of radius 10 mm. Okay, how did I know it is 10 mm? Because the question stated that the roller follower is offset by a distance of 10 mm to the right, okay, or by a distance of 10 mm. Hence, I am taking the radius as 10 mm and drawing the offset circle. If they had stated that the offset distance is 15 mm from the center, then I would take the offset circle radius as 15 mm. Okay, so in this case it is offset by 10 mm, hence I am taking the radius of 10 mm and then drawing the offset circle. Okay. Alright, so point number 2, draw vertical line tangent to offset circle to cut the prime circle at A. Okay, then draw roller follower whose diameter is 20 mm from point A. Okay, now draw a vertical line tangent to offset circle to the right of from the center. Okay, now why I have to draw it draw the vertical tangent to the right? Okay, because the question said that the roller follower is offset by 10 mm to the right of the cam center. Okay, hence I have to take the tangent line towards the tangent line to the offset circle on the right hand side. Okay, had they said that draw the roller follower is offset by 10 mm to the left, then I have to take the vertical tangent on the left hand side. Okay, but here since it is on the right, I will take it on the right hand side, and hence I draw a tangent line cutting the prime circle, and there I have named that as A. Then at that point I drew a roller follower whose diameter is 20 mm. Okay. After that, the same procedure follows. Draw a line from point A to the center O. Okay. Then on the prime circle, see, in case of a roller follower, everything happens in the prime circle. All right. So then on the prime circle, get angle AOB, which is 120 degree, BOC 60 degree, and COD 90 degree. What are these angles? They are nothing but the angle of rise, dwell, and then again angle of fall, and the remaining is the again angle of dwell. Okay. Then point number 4, on the prime circle, divide angle AOB and COD into 6 equal parts. Okay. Again, we have, you know that we have to divide the angles, angle of rise and angle of fall into 6 equal parts. Right now, so that you have to divide it on the prime circle. Okay. So and I given the name 1, 2, 3, 4, 5, and 6. Similarly, on the angle of fall, 6, 5, 4, 3, 2, 1, 0. So angle of rise 120 divided by 6 is nothing but 20 degrees each. Okay, and then angle of fall 90 degree divided by 6 is 15 degrees each. Okay, we know this. All right. Next, this is important. Draw extended lines from all these points 1, 2, 3, 4, 5, and 6 tangent to offset circle as shown. Okay, so on the left hand side you have the angle of rise portion, and on the right hand side I have drawn both angle of fall as well as angle of rise. So from point 1 on the prime circle, draw a tangent line to the offset circle and extend it a little bit. Similarly, from point 2, draw a line tangent to the offset circle and then extend a little bit. Okay. Similarly, do it for 3, 4, 5, and 6. Do the same thing for the other portion also. Okay. On the angle of fall also. Okay. What after that? Then point number 6. Keeping displacement diagram as a reference, draw the cam profile. Okay, and transfer the distances 1, 1 dash, 2, 2 dash, 3, 3 dash from the displacement diagram to the cam profile. Okay, so this also we know. Okay, take the distance of 1, 1 dash in the compass and we run a center cut. Okay, similarly get all those points 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash in the angle of rise portion as well as in the angle of fall portion. Okay, next point number 8. So with the radius equal to roller follower. Okay, because the roller follower is given a diameter 20 and the roller follower radius is 10. Draw circles at keeping at centers 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Okay, because at point O we have drawn one circle. Again at 1 dash draw a circle. 2 dash, with the 2 dash a center, draw a circle of the follower. Okay, similarly draw it for all the points, even at the angle of rise as well as in the angle of fall region. Then point number 9, draw curve tangentially to all the circles as shown. Okay, so draw a smooth curve. Okay, draw a smooth curve tangentially to all the circles as shown in the figure, in the angle of rise as well as in the angle of fall region. Okay, then to complete the sketch, okay, draw a tangent arc, okay, between the circles of 6 and 6 dash. 6 dash. Then with O as center and with O as center and radius equal to the base circle, not OA as it is written there, and the radius equal to the base circle, you can draw an arc from the circle 0 to the other circle 0 and complete the CAM profile. Okay. Okay. Then to calculate the maximum velocity and maximum acceleration, you know that this is the same thing that we have solved in the last class. So n is the speed of the CAM, which is 100 rpm. S is the stroke, that is 40 mm or 0.04 m meter. Angular velocity is 2 pi n by 60, where n is the speed of the CAM. Hence it is 10.47. Because the follower follows UARM, then the formula for maximum velocity and acceleration, we know that. Okay, so substitute these values and get the answers. So for out, we have to calculate the maximum velocity and acceleration for outward as well as for inward. For angle of rise separate and then angle of fall separate, because the angles are changed. Okay, so you know that theta r or angle of rise is 120, but for substituting we have to convert that into radians. So 120 convert to radians, degree convert to radians gives you 2.09 radian per second. So the maximum velocity is v is equal to 2 omega s by theta, where 2 into 10.47 into 0.04. Okay, s is the stroke. Okay, 40 mm means 0.04 meter divided by 2.09 gives you 4.4 meter per second. Similarly, maximum acceleration is given as 4 omega square s by theta square, that is 4 into 10.47 to the power square, it should be, into 0.04 divided by 2.09 square. Okay, that is 4 meter per second. Okay, similarly the inward angle also. Okay, now here the angle of fall 90 degree is nothing but 1.57 radian per second, and then maximum velocity is 0.533, and maximum acceleration is, after substitution and all, here theta changes, you will get 7.11 meter per second square. Okay, so today we have learned how to draw the profile, how to draw the roller follower for the offset, okay, for the offset length. So in this case the offset was 10 mm to the right. Okay, hence we had to also draw the offset circle, and then the first location of the roller follower will be to the right of the center of the CAM. Okay, and then we calculate the maximum velocity and maximum acceleration. So this is how you draw it. So hope you liked it.